Sean, you okay? Do the calculation, okay?
Oh, 44%. What is that, 37?
That's what the $1 million.
Wait, no, the $1 million was 40 people. 6 people. Okay.
Y'all do the calculation in the back?
Wait, Eric, 16 people. 6, 7.
I got it.
What is it?
37 would take the water. 37% would take the $1 million. 44% would take the water, and 19% is undecided.
Very
And the
good.
total's up to 100%.
Very good. Very good. All right. So we get the gist of it, right? Very practical.
What I did was K equals 1. This is the lowest number, and 5 is the highest number. My solution is 8, K plus 2, K equals 1. So I did the chart from 1 to 5. I multiplied 8 times 1 and added 2 to get 10. And I did the same with all the numbers, multiplied 8 by the number, which is K, and added 2. And these are the numbers I got, and the total equals 132.
Very good. You just did.
Okay, what we did was we made a histogram based on the temperatures and the frequency found in the Arizona desert. And we charted it. We went by threes because 18 was the highest number, so we went by threes. We put the frequency on the y-axis and the class boundaries on the x-axis, and we mapped it out, and we made a bar graph from the data.
So what can we interpret from the data in
Right.
terms of high and low temperatures?
Right, in terms of high and low temperatures, 109.5 to 114 was the highest, the frequency was 18, and the lowest is 124 to 129 and 129 to 134 with a frequency of 1.
What was the next highest?
Yes, the second highest was 114 to 119, which was 13, with a frequency of 13.
And the next highest?
And the second highest was 104.5 to 109 with a frequency of 8.
And the lowest?
And the lowest was 124 to 129 and 129 to 134, both have frequencies of 1.
So what does that tell you about those high extreme temperatures? Does it happen a lot?
Yes, it does.
No.
No, it doesn't.
It doesn't.
No, it does not.
Because it only happened once. It's all right. Because it only happened once.
Right, it only happened once, right. And the mode is 1 because it appears 2 times.
Very good. Now y'all better learn what the mode is because she picked up on it. Thank you. Thank you very much.
Hi, my name is Theophilus Conley, and I'll be explaining the stem and leaf scenario here that we have present on the board. Cardiograms performed over 20 days inside of a hospital resulted with the information that we've gathered here. We have 25, 14, 36, 32, 31, 43, 32, 52, 22, 33, 44, 32, 57, 32, 51, 13, 23, 44, and 45.
Is that data?
And this is our data that we're going to be working with. The first thing that we're going to look at is putting them into ascending numerical order, where we're going from lowest to highest, just to show you the relativity of how many times a number repeats itself within this equation. So once you start putting the numbers in order, 2, 13, 14, 20, we then move to the next step, which is putting the numbers into a class. And when we say class, we're looking at the number itself and what is familiar about the number in each set. In the first set, we have one independent 2. In the second set, we have a 13 and 14, which means those are 10s. Then we move to the 20s. So you got a 20, 23, and a 25. Then we move to the next set, which is the 30s, and then the 40s, and then in the 50s. Now, to explain leaf and stem, we're looking at the digit and then breaking it down into its individuality as the lead digit being the stem, which is the 0, the 1, the 2, the 3, the 4, and the 5. And the trailing digit, which is the number that follows the base number, is going to be the leaf, which in this case is a 2 by itself, a 3, a 4, a 0, a 3, and a 5. And as you can see, the 2s are repeated here in the 3 column because there's 1, 2, 3, 4 32s seen here.
That's right.
Then we move to the next step, which is the 4s. So you got 4, 3, 4, 4, and 5. And in the 5s, you got 1, 2, and 7. These are your trailing digits that go with the leaf product.